Hello, everybody. This is Mrs. Aki. Our lesson for today is about finding net force acting on an object. So we will be analyzing problems to find the total on net force in order to predict the motion of the object. So before we jump into that, I want you to go ahead and make sure that you review with your thinking partner, or you may pause this video. Think about what is a force, how did we define a force, how can we measure force, what are some examples of forces, and how can we visualize or how can we represent a force. And in our lesson for today, these are our essential questions. Our goal is to be able to answer them by the end of the lesson. So first is what is the effect of all forces acting on an object? Another one is how do we quantify the total force acting on an object? And is it possible to predict the motion of an object by looking at the net force acting on it? So let's take a look at this one. This is fun right here. I just found this picture somewhere. So take a look at Batman. And then you have the two forces right here, considering these two forces. What does this tell you about his motion? Can you say that he's just waiting? Can you say that he's unable to move? Or can you say that he is falling? So how do we know those? Again, you're looking at here, this is where we're going to come in with the balance or unbalanced forces. Now let's take another picture. This is fun. Some of you might have seen this movie. What is this picture telling you about the motion of the cheetah? Now take a look at the force that is upward and then the force that's downward, and they are kind of equal, like visibly you can see they're equal. So the upward and the downward forces will actually cancel out, and then towards the right of the screen, it is a smaller force, and then towards the left, it is a bigger force. If you remember, we represent or visualize forces in terms of the arrows. So the bigger arrows or the longer arrows would represent a greater magnitude. So most likely this cheetah will be moving to the left, right? So let's see another one right here. This angry bird. Some of you might have played this game. Now the upward and downward force are equal. They cancel each other out. So we can say that this angry bird, it's not going to go up or down. However, if you look at the arrow, the one going to the left of the screen is smaller. The one going to the right of the screen is larger. So most likely, as these four forces are acting on the object, it will most likely go to the right of the screen. So now let's go ahead and tie this into two terms that we have been using the past few days of our discussion. We have balance and unbalanced forces. So if all forces cancel out, then we can say that there is what we call as balanced forces acting on the object. Now, what is the effect of balanced forces? It will not have, or it will not cause any change in the motion of the object. So look at this one. If we have upward and downward, they cancel. And then you have this to the right and to the left of the screen, they also cancel. Then most likely this one will keep its current state of motion. So there's two possibilities right here. It could be either not moving, so it will continue to not move, or if it's initially moving, then it will continue in its motion without any change in speed. It will not speed up, it will not slow down, it will not change its direction. How about if the forces are unbalanced? So let's take a look at this gentleman right here, free falling. And then you see that the arrows represent its bigger downward right here, if you can see that gray arrow. And then has air drag acting on him, that will be upward right there. But clearly the downward arrow is much greater. Therefore, the force of gravity is making him fall downwards. Now, this is what we call as unbalanced forces, because the forces acting on the object at the same time do not cancel, do not result to a zero. So when you have unbalanced forces acting on the object, the result is a change in the motion of the object. So obviously for this gentleman right here, he is going faster or falling faster right here. So acceleration due to gravity, the force of gravity is acting on him, making him fall downwards. So now that we have identified what or defined what are balanced and unbalanced forces, how do we find out if two forces are balanced or unbalanced? Or if multiple forces, not just two, if multiple forces acting on the object are balanced or unbalanced? We will be applying math in our study of forces. So now we're going to quantify instead of just showing arrows without numbers. You already know that we quantify forces by measuring it and representing the unit with newtons. So for example, right here, we will take on some examples right here. So you have 20 newtons up, you have 20 newtons downward. The upward and downward forces acting on this crate right here cancel out. So this is what we call as a balance along the vertical, or in math, we actually say along the y-axis. So it's balanced. So it is not going to have any change in its motion along the y or along the vertical. However, let's take along the horizontal right here, or you might be familiar with calling this one as your x-axis. So the one going to the right of the screen is 15 newtons. The one going to the left is 10 newtons right here. So obviously 50 is much greater than 10. Then this one is going to be moving to the right. And then you will actually be performing a very simple math right here. 50 minus 10, and then you will see that it will have a net force of 40 newtons going to the right. So let's go ahead and do a quick recap, and you will be writing this in your notes for you to study later. Balanced forces is when the net or total of all forces acting on an object equals to 0. So it does, all of the forces acting cancels out. Balanced forces do not change the motion of the object. If it is initially moving, it will continue moving at the same speed and direction. If it is initially at rest or stopped, then it will continue to be at rest, or it will continue to be stopped. Let's move on to unbalanced forces. You can stop this video if you need to take your notes down. Moving on to unbalanced forces, it is when the net or total of all forces acting on an object is not 0. So it will be greater than 0. Sometimes it will be a negative value. So unbalanced forces cause an object's motion to change. If it is initially at rest, then it will start moving. If it's initially moving, then any of the three possibilities might happen. It will speed up, it will slow down, or it will change its direction. It's also possible that it will speed up and change direction, or it will slow down and it will also change its direction. So that is the effect of unbalanced forces on an object. So let's go ahead and do some practice problems finding the net force on the object. So when we say net force, I want you to think about finding the sum, finding the total of all forces acting on an object. And you already have learned that it is possible that there will be more than two forces acting on an object at the same time. We are going to determine the motion of the object after we find the net force. And since we are just finding the sum or the total of all the forces, the net force will have the same unit as the force, which is Newton, or we use the abbreviation big letter N. So there will be some very simple rules that I want you to remember. You can pause the video in order to write down or to review. Number one is add only forces that algebraically only if they are along the same line or axis. We are going to be using the X or Y axis just for convenience because you guys are already familiar with the X and Y axis in math. Take note that this is a very simplified approach. If they are not in the same line, you can still add them. However, that will require you to use trigonometry to find the components of the forces along the x and y axis. This is going to be in your high school physics or maybe in your AP physics. We're not going to spend time on that one, but I'm willing to talk to you guys if you're interested. So that's our first rule. Okay, so we're going to treat simplified systems only along the same axis. Rule number 2, if forces are in the same direction, what we will do is we're going to add the forces. So for example, one force is going to the right, the other force is going to the right as well. So they are in the same direction. All we need to do is add them. The direction of the net force will be the same as the direction of all the forces. So this is a very simple addition. Now, rule number 3 should be a rule right here. If forces are in opposite directions, we need to subtract the forces. The net force will have the direction of the larger force. So obviously, if there are two opposing forces, then a portion of the larger amount of force will be canceled out by the smaller amount of force. I think this will all make sense, the rules that I have talked to you, if we have some practice, but it's important that you know what we are following. So pause this video and try to review what is the net force when there are balanced forces acting on an object. If it's balanced, the net force will be equal to 0. What effect do balanced forces have in the motion of the object? It will not change the state of motion of the object. Now, for unbalanced forces, it will not be equal to 0. It might be positive, greater than 0. It might be negative to indicate the direction, and that will be less than 0. What effect do unbalanced forces have on the motion of the object? It will change the motion of the object depending on the amount, the magnitude, and direction of the net force. So let's take on some problems right here. This is problem number 1. Two forces are identical to act on a cart. The strength of each force are shown in the free body diagram. What is the net force acting on the cart? So I am going to go ahead and share my other screen. And what you will do is follow through our calculations. Okay? So let's go ahead and continue problem solving this. And let us simplify by drawing our free body diagram. So we have, remember, we always represent the object as a dot only. That makes it simple. And then we have 10 newtons, which is directed to the right. And then we also have 10 newtons, which is directed to the left. So I'm just going to go ahead and label this one right here. Now, if you remember what we have said earlier, that we will be simplifying our systems. So this is along x right here. So this is negative x. This is positive x right here. So can we add them? Can we find the net force? Yes, we can find the net force. So what will we do? In order to find the net force, you are just going to designate which forces you are adding. And this one becomes very arbitrary. So we can assign this, okay, this is going to be my first force. This is going to be my second force right here. And so in order to do that, let me go ahead and change the color of my marker so that you can actually see it. So F1 is 10 newtons and that is to the right. So I am going to go ahead and put 10 newtons right here. And then F2 is to the left. And then I'm going to designate, remember they're opposite. So I am going to subtract. You can also take that it is going to the left. So that sign right there is going to be negative. So that will be negative 10 newtons right now. So obviously 10, positive 10, minus 10, that will give you 0. So the net force for this situation is equal to 0. Now looking at this, you remember this free body diagram? Now you will remember that we represent the force in using our arrow, and then they're most likely equal, right? So now you will say that the net force is equal to 0. And then you'll be asked, what is the effect? Is this balanced or unbalanced? This is balanced because it's equal to 0. We have satisfied that condition. Will the object's motion change? The answer will be no, it will not change. And then it will continue whatever it's doing right now without change in speed, without change in direction. If it's stopped, then it will just continue to be stopped or at rest. Let's continue on to the next problem. So go ahead and move on to problem number 2. I will go ahead and clear my screen right now. So problem number 2, I'll read it to you and you can read it in your paper as well. 2 forces are identified to act on a cart. The strength of each force are shown in the free body diagram. Let's go ahead and simplify that. What is the net force acting on the cart? So let's represent the cart in, see, this is the cart right here. And then we have 2 forces. One force is going to the right, okay? And it says it's 20 newtons. The other force is going to the left and it's 10 newtons. Again, we already have learned representing the forces in terms of arrows in our free body diagram. Now you should understand why the 10 newtons is shorter than the 20 newtons that is in our free body diagram. So the question is, what is the net force? So the net force will be equal to Fn, or net force, will be equal to the number of forces that are in there. Can I actually switch? Yes, you definitely can switch. Again, labeling the forces is arbitrary. So F1 and then F2 right here. So we're just gonna add them, right? F1 plus F2. Now I'm going to teach you something else that you will be more familiar with, or I want you to make sure you can use what you know in math right here. This is your negative x-axis. This is your positive. This is your positive x-axis right here. And let's take on the signs of the axis to actually solve this problem. Now, teaching you this method will make it a lot easier because you're connecting this to what you already know in the convention of your x and y axis in math. So your 10 newtons right here is negative to the negative value. So we're going to have negative 10 newtons, right? And then my 20 right here is to the positive x, then I'm going to include that. That will be positive 20 newtons right here. You will notice, had I done this differently, opposite, had I called this positive, had I called F2 as my F1, or had I called F1 as my F2, it will have the same result. Let's show that one. So what do I mean? So it's like right here, if I put 20 newtons first, that will be 20 newtons, but I know that it's positive, it's towards the right. And then I have my negative 10 right here, which is to the left. I'll just put negative 10 newtons. So if you look at this and then this one, they actually will give you the same result. So now you have 20 minus 10 or negative 10 plus 20, you will get a positive 10 newtons right here. Now, balance or unbalance, this will be balance, right? You have balance, unbalance, I'm sorry. You have unbalance. And then will this affect the object's motion? Yes, it will. If it's initially moving, it will go faster towards the right. If it's not moving initially, then it will start moving towards the right. So you can think about, this is a cart that is on the floor and you're trying to push it towards the right, and you have applied 10 newtons force greater than the amount of friction, you're able to counter the friction. So therefore, you're able to move the cart along the floor. So this is how we solve this, how we find this one. Let's go ahead and take a look at the next problem. Next problem is going to involve three forces. Now, what I want you to do is pause the video if you need to look at this, and we are going to go ahead and move on to problem number 3. Okay, so problem number 3, I'm going to read it with you, and you're going to go ahead and take a look at your paper. 3 forces are identified to act on a cart. The strength of each force are shown in our free body diagram. What is the net force acting on the cart? So let's go ahead and take a look. And again, let's represent our cart. That will be our cart right here. And then the 3 forces, there's one force that's going to the right. It says it's 10 newtons. And then there is another force that's going to the left. It says it is also 10 newtons. So I'm going to just label that. Now the third force is going up. Let's go ahead and represent that one. And that will be 10 newtons as well. So now you'll be like, wait, they're not on the same axis anymore. So what are we going to do? So now we're going to break this down. Let's break this down into 2 components. So this is your X, and then this is your Y right here. So let's go ahead and do that quickly. So we will have 2 solutions. So let's deal with the X part first, okay? So what is the net force along the X axis right here? So now we have right here, okay, positive 10, right? So 10 newtons, this is right here. And then we're going to add, because you're finding the net force of the negative 10 right here. So we're going to add the negative 10. So adding a negative value, that means you are actually subtracting. So along the x-axis, you will have 10 newtons minus 10. That will be 0 right here. So along the x, now we know that it is balanced. Now, what is the implication of this? That means along the x-axis, this object is not going to be changing its motion. So there's because of the balanced forces. Now let's go ahead and take a look at along the y. So I am going to go ahead and focus along the y right here. So I am going to use a different color right now. So along the y-axis, or if you want to use the vertical, that's also okay to help you remember y is the vertical. So what is the net force along the vertical? So net force along the vertical is we're going to add all the forces that are present in it. Now, how many forces do you see? We only see one, and that's only the one going up. So we can designate that as your positive. Again, we're just using the convention that you already know in or from your math. So we're going to put 10 newtons right here. Are there any other forces? None, right? So you're just going to have 10 newtons. So that will be 10 newtons. So along the y, you will have a 10 newton as your net force. So along the y-axis, it is going to be unbalanced. And what does that mean? That means that your object is going to have a tendency to change its motion towards the positive y or upward of this page right here. So it will move, it might move, or it might go faster in this direction. So that is what it means. So now, can we combine this? Yes, you can combine. Again, this is where you will have to use higher math or trigonometry. So we're not going to go there. It's enough that you're able to break it down into 2 components, the x and y. Okay, you may go ahead and pause this video if you need to. We are going to move on to our next problem, which is going to be problem number 4. Problem number 4 is going to be very quick right there. So I'm going to go ahead and start with our free body diagram while I am reading. A chandelier hangs on a metallic chain and the force of gravity on it is 15 newtons. And you know that force of gravity will always be downward. So that will be 15 newtons right there. Now, you will notice that we are building on a lot of what we have already learned. You know that the force of gravity is the weight, so that's downward. And then while the tension on the chain is also 15 newtons. So there is a tension on the train, and you know that is one of the forces that you have already when you have a chain, a rope, or a string, that will be what we call as tension. And it is also at 15 newtons. Now the question is, what is the net force for these two forces acting on, it should be chandelier right here, acting on the chandelier. So let's go ahead and take a look at that. And now you will notice that we are dealing with the y-axis. We're not dealing with the x-axis. So we'll go ahead and do a designation following what you know in math. When you go up, that is positive. When you go down, that is negative. Okay, so simply put, we're going to find our net force, which is equal to, how many forces do we see? We have two forces. So we're just going to go ahead and F1 plus F2 right here. Can we put this as our F1? Yes. Can we switch? Yes, as long as you know the directions. Okay. Again, this labeling right here is arbitrary. So this is arbitrary. That means you can assign, and it's up to you what you want, as long as you know which is your positive and which is your negative direction. So our F1 is on our positive, that is 15 newtons. I'm going to put 15 newtons. And then our F2 is 15 newtons, but it is on the negative. So I'm going to add that negative value, which is also 15 newtons. And so the net force will be equal to 0. So on this chandelier right here, the net force is equal to 0. Therefore, it is balanced. Is the chandelier going to be moving? Thank goodness it's not going to be moving. It's stable. We will be scared to see a chandelier that's going to be bobbing up and down, right? So that will be at rest. Okay. All right, go ahead and pause the video if you need to go ahead and take a look at this solution a little bit more. I will go ahead and move on to problem number 5. So for problem number 5, we just added a little bit on this one. I will go ahead and draw our free body diagram for number 5 while I'm reading it to you. While the chandelier hangs in the ceiling, a strong industrial fan is facing it, exerting a wind force of 20 newtons to the left. What is the net force for these forces acting on the chandelier? So when you go back to, this is a continuation of number 4, we already know that there is a force acting on our object, and that is 15 newtons downward, because that is the weight, the force of gravity. We also have our 15 newtons upward, which is the tension along the chain that keeps it hanging up on the ceiling. And then now you're adding something. There is a fan that is exerting a force to the left. So this is going to be right here. And it says it's 20 newtons. So I purposely made sure that this 20 newtons right here is a little bit longer than the 15 Newton arrow right here. So what we will do is we're going to break this problem down into 2. Luckily, we already did the first one. We already know that along the y-axis, that the net force along the y-axis is simply 15 newtons up minus 15 newtons down. We know that it is already 0. So now our remaining concern will be along the x-axis. So we're going to go ahead and take a look at that one. Along the x-axis, we're going to find our net force. Net force is going to be equal to, how many forces are we looking at? We only have one. So all you need to do is put your 20 newtons. And hey, do not forget that this is along the negative x based on the convention that we follow. Therefore, now what you will have is a negative 20. Now, what does a negative 20 mean? It means there is a force negative 20 to the left. So are the forces in overall acting on the chandelier for problem number 5 balanced or unbalanced? This is what we call as unbalanced, because along the x-axis, there is a net force going to the left. So this is unbalanced. What will be the effect? The effect is, obviously, you will see the chandelier swinging to what direction? To the left right here. That is because that shows you the effect of this net force right now. So hopefully that helped you. Again, watch this video as you need to, and then review. And then we will have, this is a practice, and then we will have our actual finding net force problem solving in the class. Thank you so much for listening.